What we're looking at here is an APC XS1300. I liberated this little beauty from a tri-cell or dumpster in the back of a, what do you call those, business park? And of course I took it home and plugged it in. Low battery, needed a new battery, no problem. What was it, 35 bucks later, it's back in business and ran for about 2 years. Now, it has recently started making a nice little chirping sound. And you can see that the battery connection, the battery status is pretty much hooped. It's got nothing on it, it's plugged in. So, you know, buy new batteries, right? Immediately I bought new batteries. And then as I was waiting for those to come, I was dicking around with this and realized, oh, it's not the batteries at all. This thing's not charging. So my batteries are fine, and now I have a brand new set for no good reason. So I'm going to take this apart. We're going to look to see if there's anything we can do to fix it. And because I don't want to buy one of these. I like this, but good God, they're like $200-300 bucks. It's crazy. We're going to do our best to fix this thing. Let's take it apart. I see a screw there, I see a screw there, and there are 4 screws on the back. Let's start with those. Well, that was easy. Pull this part here, so that's what, 5? And might as well take this one off too, I guess. Doesn't really look like it's hooked into much except for this wire, which God knows what it does. Anyway, off it goes. Oh, there's got to be something else holding this together. Oh, look at that. I see crackage. So I bet this thing just pops off. There we go. Wait for it. There they are. 1, 2, 3. That's what's keeping us out. Okay, now I think that's going to be it. I think. Yeah, there we go. Look at that. All right. So how about we disconnect this and move this out of the way? And by this I'm talking about this, because you can't see what I'm doing. Brown, blue, blah, 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 bunch of wires. So we got 1, 2, 3, 4, maybe 5 connectors there. Oh, a couple more, 6, 7. Yeah, better take a picture. Brown, is that written on there? Blue. Oh, do you see what I see? Probably not. I think I see what's the problem here. Come on. Oh, I can't get it. Can't get it. I'm too weak. Little girl arms won't do it for me here. That is effed up. Oh, there we go. This is this capacitor, I think that's what it is anyway, is totally smoked off. So it's pretty easy to tell. Like you can see the smoke stain here. Just gave it right up. So what does that mean? That means we got to replace that. We can remove that easy enough, but yeah, no idea what part that might be. I mean, it could be one of like this, but how the hell am I going to know for sure? Yeah, I might as well just pop that thing off. Alright, there we go. Now we can get a better look at that. I'm looking for like some sort of indication of what might have been placed there. Like you can see on these ones here it says C5, C4, which is capacitor. Oh, MV they are, eh? MV. Oh, and conveniently there's all sorts of carbon scoring right there where the number would be. What does MV stand for, I wonder? Just to be clear, I am not a professional and have no real knowledge of what I'm doing. I just figure I should be able to fix it. I think it's MV1, maybe. Maybe it's just MV1. Okay. So I think we need to find out what the hell MV stands for. So as best as I can figure that MV probably stands for micro via, which has something to do with the way the PCB board is laid out. So totally shit out of luck here. But am I? Because I'm not ready to give up that quickly on this thing. All of the other ceramic capacitors that are around it are this type, this very same type, which because of my eyes suck, I can't actually read, and you probably can at this point. S14K blah blah blah, something like that. And so I'm going to look that up and see if I can't get my hands on some of those and pop one in. What's the worst that can happen? Blows up and we're back to square one. So that's what we're going to do. Just searching for S14K230 brings up this guy here and the data sheet, and guess what? It isn't a capacitor at all, because I'm an idiot and don't know what I'm doing. It turns out it's a varistor, which is a variable resistor depending on the voltage. So it's a good thing I checked, and now I know something I didn't know before. Yay! If we search the data sheet for S14K230, that's right here. And we can see the 230 comes from the number of volts, and the 14 is actually how many millimeters across is the thing. So yeah, and then there's some other specs here. I cannot find this on this number on DigiKey, but maybe we can find this one, whatever all these numbers mean. So let's just copy that, and we'll just pop that in here and see what it comes up with. Boom! So yeah, that looks about right. And does it have exactly the same number as what I pasted? Yeah. So whatever those numbers mean, this is from TDK, but exactly the same thing. And what do they cost? Oh, 52 cents. All right. Well, we could probably get a few of those for that. I will order and we will fix.
Most excellent.
All right, let's see what the DigiKey fairies brought me. You know, the problem is you can't order just one thing. That would be insane. A LoRa antenna. I tried to make one of these and it sucked ass. So I thought I'd buy one. They were kind of cheap. We'll see what happens with this thing. Anyway, that's for a future video. Where's what I really want? There they are, right there. Nice. So, let's pop it in, see what happens, eh? So first things first, we're going to have to clear out those holes where the part goes, and I marked on the back where, I believe, yeah, where the part comes through. So we'll just desolder that stuff and stick it in. And I'm going to attempt to clean out these holes with some wick stuff, solder wick. Let's see if we can't get them open enough so I can get that thing through there. It's through, eh? That one's clogged up again. All right, let's see if we can't get this thing to fit in here. All right, snugged down. We just have to solder off the other points here. And just pray to God that those contacts are not all shot from me fucking around with them constantly. Nice big glob of solder. And flush those off. I don't know, man. There it is. Let's see if I can't figure out how to put all this stuff back together now. I'd say the odds are about 50-50 at this point. Alright, it's been a fair few days since I had a look at this, and I'm not entirely sure I'm going to be able to put this all back together correctly. Hopefully I won't have to use the pictures, but something tells me I'm going to. So all of the contacts seem to have a color. And I hope, see, there's a white here and a white here. So, and I know this one is white, but I'm just guessing that is the in because it's coming straight from the transformer. I will look at the pictures because this is crazy. All right, well, it looks like the yellow is over... Oh, those pictures are not helpful, man. Who took these things? Good God, what an idiot. This gray, yellow, blue right here. What have we got left? We got this shabob here. Oh, I bet this black. Was this the thing that gave me so much trouble? I bet it was. And that, I think I see this one. No, that's not there. That's here. It's all coming together, people. Fuck yeah. Yeah, what is that for exactly? 3 and 3. That looks like those. Yes. Okay, well, before we get too crazy here, I'm going to have to slide this all back in and tidy it up. And then, yeah, we'll meet you on the other side. Oops, I almost missed a couple of connectors here. There's two, like, right behind the big heat sinks. And there's a white and a black, and they go to the transformer. So don't forget about those. And yes, that other connector did go in there. So we're all good. There's little notches here in the PCB so that the wires cannot impact the case, which is great, except it's a little hard to get them all lined up. What's in the way? Alright, sweet lordy mama, that was not easy. And I'm going to show you why so that you don't have to go through this bullshit. If you line this up, there are notches here that interface with the PCB. And I know you probably can't see that very well. Can you? Not a heck of a lot. Fuck! Alright, any better? Alright. So these notches here in the top have to slot along the PCB. Now I thought these gouge outs were for the wires, and it's probably true for this big chunk here. But for the rest of them, you got to get the wires out of the notches. So for example, this black one seems to want to go in there in this little slot, but actually it interfaces with that. So if it's in the way, you're fucked. And so yeah, make sure that all these ones are clean. Okay, are we clear? Once you've got that, then you'll get it halfway down and realize it's not fitting, and you have to slide the PCB. Bit of the COVID there. Holy schmoly. Alright. Zoom function. Okay, you can see this, the PCB here poking out. You have to like give that a little shove to get it in the right place. Otherwise, see, there it goes. And then do the same thing for the other side. And there you're in. Woo! Now you can just put the end pieces on and Bob's your uncle. Oh, for feck's sake, eh? Okay, this is, I'm pretty sure it was supposed to go through here. I have 2 extra screws for some reason. I can see one because I know one of them was this. And this, my best guess, is this thing is a thermistor. So if the batteries start on fire, I guess it cuts power to the thing or something. Anyway, it's a sensor. That's all that is. So that is actually supposed to go through that hole, which you need to do before you put the case together. So yeah, then I'll hopefully be able to figure out where the last screw goes. If not, fuck it. Alright, just for the record here, 3 screws here, 1 inside the battery case, 4 at the back, and 1 for that frickin' thermistor, which we're just gonna fix now, which is a total of 9. Hooray! I actually have all the screws, so there. Bully on me. So there you go. Black and white in there. No, what am I talking about? Black and red in there, and then that thermistor goes through that hole there. Got it? Got it. Alright, battery's back in. Only one problem. I can't seem to find the lid for this thing. No worries, it'll show up, I'm sure. I can't have thrown it away, can I? See? What did I tell you? There we go. And we're in. Now, let's flip this bad boy over and see what we got. Don't rightly know how this thing works because it just sits there and does its thing, but what? Oh, there we go. Press and hold, I guess. All right, so battery, some battery there. I guess the question is it going to charge the battery? That's the problem. Or is it just going to discharge it and we're hooped? So let's plug it in. And see how it goes. Ready to let it charge overnight and... Oh, what the? 2 bars? That ain't right. Alright, so what the hell's going on now? Oh, 24 volts, so they're fully charged. I was snooping around on the APC website and it seems like these might just be out of calibration. This machine is supposed to come with a special cable, and one half of it plugs into this sort of Ethernet-y cable here, and the other is a USB end, and you plug it into your computer, and then they've got special software which allows you to calibrate the batteries. Now, I don't have that cable because I got this out of a dumpster. So there's a manual way of doing it, and it involves completely discharging the batteries and then recharging the machine back up, and that should recalibrate it. So this is probably a similar procedure for all these APCs, I think, because it didn't specifically mention this one. So what you have to do is you have to drain the batteries with a 30% load, and you can actually determine the load on this thing by... Come on. I should really look at the... Oh, and now we have 3 bars. Oh, now it's down to 2. So, who knows? Okay, so you need 30% load. And what was I saying here? 1, 2, 3... Load. You can do... switch this to load. And we're just going to plug a whole bunch of shit into it and let the thing drain right down. Oh, okay, 30%. So we just let that run down. You can see the bars have gone up again for some reason. So we'll just let it completely drain until everything goes off. All right, it's all dead. It took about 10 minutes maybe, so yeah, it wasn't too far off. Now all you have to do is plug it in and let it recharge. Okay, let's fire up the tower of power and... What the What's going on here? Well, as you can tell, that did not work. This obviously was totally wrecked, but it wasn't the problem, I guess, because no charge overnight. So I have been inspecting the board for other problems, and the only thing I can come up with is this capacitor here, which you can maybe see is kind of domed. See, it's splitting at the top there. So I'm got my fingers crossed that that is the reason it's not charging the battery. So that is the next part to replace on this. Oh, beauty, eh? Time for a little decapitation. Looks right to me. All right, time to put the band back together. Oh, for fuck's sake. What in the fuck is going on here? So, despite this capacitor clearly being on its last leg, not this one in particular, but it's not the problem, because still discharging the battery. I'm into this thing for $1.50 already, and I'm going to be damned if I'm going to lose that investment. I'm going to have a look around and see if there's anything at all that I can do. So the battery is discharging. That makes me think maybe there's a flow issue here. The electrons are just not going in the right direction, and the only thing I can think of that does that kind of thing that I can test is a diode. So I went through the diodes on the board, and how can you tell what's a diode and what's not a diode? Well, one clue is that they usually start with a D on the little the PCB. You'll see it says D39 there. Up here, D7, and most of the time they'll look like a diode, like this guy here, with, you know, like a black cylinder with a band around one end, and the band tells you which side the cathode is on, the negative side. Other times they're going to look like these guys here, which are surface mount variety, and there is, I think these ones in particular, you can tell the cathode because it's got a little groove on this end. It's not present on that end. And also, we're kind of lucky here because these are marked. So the anode, the positive side, is on this side. So yeah, anyway. So I went through all the diodes on the board to see, you know, are any of them good? And you can just put your multimeter on diode mode, which I don't have it on. There we go. Is that little symbol there, the diode symbol. And then if you, are we going to be able to see everything going on here? Maybe. Okay, so we'll just test this one here. Oh, we're wrong way around. Do it this way. So you can see we get a reading off of that. I don't know what that reading means, but the fact that you get a reading tells you that it's not an open circuit, right? So here's some other ones. Surface mount variety. You can see these ones also give you a reading. These ones over here. Same dealio. Anyway, I got down to these ones by the capacitor here that I just replaced, and I checked this one, and it gave me a reading, and I checked this one, and it gave me a reading, but these guys in the middle, boom, dead. This one, boom, dead. And the proximity to our charging cable here makes me think that maybe this has something to do with why it isn't charging, because these should definitely be doing something. Also, when you have 4 diodes lined up like this, sometimes it means it's a rectifier, which means it's going to change AC to DC, and you're going to need DC to charge the battery. So, just to kind of illustrate what's going on here, you can actually look up at this through the light. Where are you? God damn it. There. Okay, so you can see those 4 diodes in the middle there. How can I do this so that you can see? And you can see that the, oh yeah, what is it? The anode, no, the cathode of one end is connected to the anode of the other, and the same with that pair there. And I can't really see what's going on in the background with the other ends of those diodes, but, it looks suspiciously like this arrangement here. 4 diodes in a kind of a chain formation, and a transformer on coming off of one end there, and this side goes to a filter, which maybe that's our capacitor, and the transformer is actually this thing here. Not your traditional looking transformer, because didn't recognize it immediately when I saw it, but it is this toroidal transformer arrangement. So I think we're totally along the right lines here. These could be the problem. That is them there. They are not the exact same brand, but the specs are the same on them, so there shouldn't be a problem. Cost 22 cents a piece, so now we're creeping up on $2 for this repair. Surface mount shit can be a bit tricky to get on and off. They'll take your money and leave you crying in the dark. To desolder them, it's a good idea to just add some solder and heat it up, and there you see it'll slide right off. So that's a bad boy. Okay, I think I got it. Ooh, come over this way a little bit, guy. There. Yep. Nope. Oh, you dirty. Okay, I feel like that's down. I'm just going to press on the top here. Get a little heat. Alright, well, doesn't work. I got more of these to play with, eh? There. Let's hope that the next scene isn't me staring at a circuit board. My spidey sense tells me that we're going to be good here, but oh, have I been wrong before. Well, I don't know who that idiot was from the first part of the video, but if you want to save yourself a bunch of time, effort, and probably money, don't get all giddy excited like a schoolgirl at the first fixable problem you happen to find. Take some time, go over the whole board, and try and figure out what's working and what's not. Had he done that, he would have discovered that this little device here is a fuse, and usually they're marked with an F number thing. This fuse is actually blown, and you can tell that by just putting your multimeter on continuity, and that's where it gives the little beep beep when you connect the contacts, and you can see that this one, no. And I just happen to have one of those. Where is it? from fixing a stove that I did. So here's the replacement part, and you can see that we get good contact through there. So that tells you that that part is also shot. Now, another thing you can do is you can have a look at these things, which are relays, the big black monoliths. So for these relays, what you want to do is just energize them and make sure that they do something. And you can see the pins come through here. There's a set of 6 pins and a set of 2. It's the set of 2. You can look on the data sheet to see what's what, but the set of 2 is where you energize it. And also, it'll tell you right on here that this is a 12 volt DC relay, which means it's triggered by 12 volts DC. So in order to test it, all you got to do is put some juice through here. So we'll do that. Now I happen to have a little power supply here, but you can do this with like a wall wart or a car battery, anything 12 volts, you know, 5 volts if it's a 5 volt one, whatever. You just have to throw some energy in it. And let's see, where are we here? So let's have a look at this guy here. And you can hear that, it's clicking, right? And then this one here is these 2 contacts here. We'll give it a little energy, and nothing. So this thing is also hooped, which is right by the fuse, coincidentally. Now another thing you can check is these automotive fuses. Super easy to check. You can see there's little contact points on the top, just to make sure there's continuity between each of them. If there's not, desolder them, put a new one in. You probably have them in your glove compartment. So yeah, that's about it. I'm gonna swap those out, and fingers crossed that's the end of it. If not, I'm not quite sure what to do next, but we'll cross that bridge if we come to it. So the fuse is 80 cents and the relay cost me $4. Yeah, I know, big expensive item. So that brings our total to about $6.75, which puts us, yep, fucking way over budget. But what are you gonna do? There is our starting point. Let's see if Mr. Battery Bar goes up or down. Bar goes up, bar goes down, bar goes up. Okay, let's poke the beast and see what happens. Oh yeah, there you go. There's the money shot right there, full battery. You don't know what kind of relief that is for me. 440 beautiful minutes of runtime with absolutely nothing plugged in. So I think we're going to call this fixed. It would be against my own best interest to tell you not to throw out these battery backup units, because that's where I got this one. And this one, bad fuse. And this one, dead battery. All I'm saying is that for $7 worth of parts, maybe it's worth trying to fix it. I actually did contact APC about having this unit repaired by people who actually know what they're doing, and they told me they don't repair them. So yeah, that's kind of bullshit, because there's actually nothing wrong with this thing. It's just a handful of parts and a little bit of time and you've got it back and running again. It's pretty indicative of the whole disposable mentality that we've got these days. In any case, hopefully you found this probably way too long video useful for repairing your battery backup. Thanks for watching. Cheers.